Next, we're going to take a look at joints. So joints are actually also known as articulations. So articulations are the site where two or more bones meet, and joints or articulations are the weakest part of the skeleton. Functions of joints are to give the skeleton mobility, but also to hold the skeleton together. Now, when we say articulation or we say joint, we're not talking about types of movement. We're not talking about structural components. So we're just really talking about the site where two bones meet. But we can classify joints further. We can look at the structure, the materials binding bones together, and whether or not there is a joint cavity. We can also look at their function. So that's what type of movement they're capable of. So there are structural and functional classification for joints. Test yourself. If you have joint A and it's held together by dense fibrous connective tissue, that description of joint A, is it describing its structural or its functional classification? So we're talking about dense fibrous connective tissue holding together joint A. Because we're talking about what's holding it together, the materials binding bones together, this is an example of structural classification. But we can go further. We can look at functional classification. We can look at the specifics of it. For example, the different types of movement that are allowed by a joint. Some joints are immovable. That means they are synarthrotic. Others are slightly movable, and we would say they are amphiarthrotic. And most of the joints you'd probably name, like the shoulder joint and the hip joint, your elbow, they are considered diarthrotic or freely movable. So synarthroses, amphiarthroses, and diarthroses are the three functional classifications of joints. We introduce those first because we want to kind of tack on to the functional classifications, the structural classifications, and start to talk about them together. But there are also three structural classifications of joints: fibrous joints, cartilaginous joints, and synovial joints. Now we'll start with fibrous joints. Fibrous joints have no joint cavity. They are, hence their name, joined by fibrous tissue, and most of them show no movement or are synarthrotic. A great example is a gomphosis, or a peg and socket joint that we see between your tooth and its alveolar socket of your mandible or your maxillary bones. So this is an articulation, again, between tooth and bone. But there are other types of fibrous joints besides a gomphosis. There is a syndesmosis, which is most ligaments, or sutures, which is dense fibrous connective tissue between skull bones. When we're talking about fibrous structural joints, we oftentimes are implying the functional classification, which again is synarthrotic. Let's take a closer look at sutures. They occur between the bones of the skull. They are combined with both fibrous connective tissue and the interlocking junctions of bone that makes up the skull bones. And this is going to be great for binding bones tightly together, but it does allow for a little bit of growth during youth. We actually don't see sutures exist for the entirety of our lifespan. At about middle age, the skull bones fuse, and then they're called synestoses because they're completely bony junctions at that point. So here's an image of a suture. Again, we can see the interlocking grid of the skull bones and that very kind of thin layer of fibrous connective tissue between the skull bones. This is a suture. A syndesmosis is what we generally call a ligament, especially a short ligament, and ligaments connect bone to bone. Now, when we talk about syndesmoses, they're mainly immovable, but longer ligaments do allow for some movement. Here we see a connection between the tibia and the fibula down at the distal end, closer to the foot. We would also be able to see such a ligament between the radius and the ulna, which are of the forearm. And here's that gomphosis we talked about. The fibrous tissue here that's holding the tooth in its socket is called the periodontal ligament. So this is a peg and socket fibrous joint, and we see it here being pointed out in the mandible and how teeth fit into your jawbone. The teeth also fit into your maxillary bones, or the bones just below your nose. And so we do have these gomphoses, or this peg and socket joint, for both your upper and lower teeth. All right, so that's fibrous joints, pretty basic. Now let's look at cartilaginous joints. Hence their name, they're made up by cartilage. They unite bones, or they articulate bones together with cartilage. And they also, like fibrous joints, lack a joint cavity. And there's two types, synchondroses and symphyses. So let's talk about the synchondroses first. All synchondroses joints are not only cartilaginous joints, but they're made up of a bar or plate of hyaline cartilage. That's what unites the bones in a synchondroses. They are all synarthrotic or immovable. Great examples are the epiphyseal plates of children, where we have hyaline cartilage between the epiphyses and the diaphysis of a long bone. Also, the costal cartilage between your ribs and your sternum. These are areas that don't move, but they are cartilage connecting bone. Again, if it's a synchondroses, it's hyaline cartilage connecting two pieces of bone. Here we can see a couple locations where we have synchondroses. So we can see it between the epiphyseal end and the diaphysis, and that's of the humerus. We can see it in the costal cartilage, where the ribs connect to the sternum. And there's even some hyaline cartilage in the intervertebral disc, but that's mainly going to be on the surfaces of the vertebrae, and we don't really point to it as a kind of common synchondroses. All right, moving on, we're going to look at a symphyses. A symphyses is going to be an area where we have fibrocartilage, and that's going to be kind of an intervening pad of fibrocartilage that fuses two bones together. These are all slightly movable joints. They also tend to have some elastic tissue or some type of flexibility. We find them in areas where we find fibrocartilage, intervertebral joints between vertebrae, and at the pubic symphysis. The pubic symphysis is a location for a pad of fibrocartilage on the anterior surface, or anterior articulation, I should say, of the hip bones, of your pelvic bones. Here we can see on the right the pubic symphysis, that pad of fibrocartilage that is allowing the two hip bones to articulate or form a joint at the front, or their anterior articulation. And we can also see fibrocartilaginous intervertebral disc demonstrated or shown on the left. And that finally brings us to synovial joints. And these are going to be the joints that finally have a joint cavity. And a joint cavity is a fluid-containing cavity. Most of the joints you'll probably list, like all your limb joints, really most of the joints of the body, are going to be synovial joints. And we'll look at more examples. All synovial joints are freely movable, so we would say they exhibit diarthroses, or that synovial joints with their joint cavity are diarthrotic. So that's kind of the basics for the structural and functional classification of joints. It's a lot of new terms to look at, so make sure you go back and review, and also watch the next part of the videos where we're talking more about synovial joints.